As shown in this artist's impression, Oumuamua is apparently very long and narrow, with an axis ratio of about 10:1. Assuming it's dark, this means it's about half a mile long. Nothing else in our solar system looks like this.
Ladies and gentlemen, stargazers and cosmic explorers, welcome to Spaceverse, the channel that will take you on an extraordinary journey through the boundless realms of the universe. So get ready to embark on an interstellar voyage with us, where science meets wonder and curiosity knows no bounds. Together, we'll explore the vast and wondrous universe. So let's start. In the boundless expanse of interstellar realms, enigmas are plentiful, yet none have seized the collective imagination as profoundly as the enigmatic traveler known as Oumuamua. However, when it made its initial pass through our celestial neighborhood in 2017, Oumuamua left researchers both bewildered and captivated. Its peculiar form resembling a cosmic cigar, and its perplexing acceleration ignited a plethora of queries. Yet now enter the audacious Elon Musk, proclaiming the triumphant reappearance of Oumuamua, accompanied by an entourage. But what truly lies within this elongated enigma? Is it a celestial rock, a vessel from the cosmos, or perchance something more sinister and extraterrestrial? Embark with us on an odyssey into the uncharted cosmos led by the visionary Elon Musk as we unveil the unforeseen and abrupt return of Oumuamua, a cosmic riddle awaiting unraveling. Back in October 2017, something extraordinary unfolded right here in our solar neighborhood. The Pan-STARRS-1 telescope, stationed at the University of Hawaii and renowned for its prowess in spotting celestial debris, stumbled upon a cosmic wanderer of unprecedented proportions called Oumuamua. This interstellar traveler was found loitering in the vicinity of Maui's Haleakala volcano, prompting a sensation in the world of astronomy. Now, this telescope has peered into the depths of space and witnessed countless celestial remnants, even those as faint as Oumuamua. Officially named as 1I/2017 Yuan, this enigmatic voyager was christened with the evocative name Oumuamua by the Pan-STARRS team, a moniker that whispers messenger from afar, arriving in Hawaiian in the lyrical tongue of Hawaii. As this cosmic guest first graced our celestial stage, it presented itself as a peculiar elongated entity donning the appearance of a colossal cosmic cigar stretching roughly a quarter mile in length, dwarfing any asteroid or comet our solar system had ever encountered. Its singular shape held the promise of unveiling secrets about the formation of distant star systems. But what set Oumuamua apart, aside from its unconventional form, was its velocity, a blistering pace that far exceeded the gravitational pull of our Sun. This extraordinary celerity set it apart from the countless objects inhabiting our solar neighborhood, boldly proclaiming its origins beyond our celestial borders. Now here's where the plot thickens. Oumuamua sprinted past Earth at an astonishing 196,000 meters per hour. A staggering 109 times faster than a speeding bullet, leaving no room for doubt about its extraterrestrial roots. Initially, scientists found themselves in a cosmic conundrum, unable to definitively classify Oumuamua as either an asteroid or a comet. Initially dubbed an asteroid upon its solar dance on September 9, 2017, Oumuamua soon flirted with comet-like behaviors, leaving experts scratching their heads. Telescopes worldwide diligently observed this celestial wanderer, unveiling its peculiarities. It lacked the typical dusty tail associated with comets, and its elongated form, 10 times longer than its width, defied convention. Its reddish hue, reminiscent of outer solar system denizens, added to the mystery. But Oumuamua was no cosmic novice. It had been roaming the Milky Way for countless eons. As it bid our solar system adieu, it executed an unexpected acceleration, challenging the gravitational constraints of our celestial realm. This boost bore similarities to the propulsion of comets via evaporating ice, yet Oumuamua's speed and trajectory remained at odds with conventional predictions, propelling it further into the realm of cosmic enigma. Since its discovery in 2017, scientists have engaged in a spirited discourse concerning Oumuamua's composition, origins, and its remarkable velocity of 196,000 miles per hour. Various theories have emerged proposing that it might be solid hydrogen transitioning into gas through interaction with stellar environments, essentially morphing into a natural ion engine. Others conjecture that its shape might be more disk-like, driven by an intricate pattern of acceleration. Meanwhile, some audaciously entertain the notion of it being an alien-designed light sail, an idea met with skepticism. A defining characteristic of Oumuamua is its elusive form, often depicted as a cigar, but possibly more disc-like. Unfortunately, we've had but a limited glimpse of this enigmatic traveler during its sojourn through our solar system, leaving its true nature shrouded in mystery. The question continues to tantalize scientists and stoke the fires of curiosity. However, come October 2018, Dr. Shmuel Bialy and Professor Avi Loeb stepped onto the cosmic stage with a theory that injected fresh intrigue into the Oumuamua mystery. Their groundbreaking research, accepted for publication in the esteemed astrophysical journal Letters, put forth a bold proposition. Oumuamua's peculiar pancake-like shape and remarkable reflectivity might resemble that of a light sail. Picture it as a cosmic sailboat harnessing the gentle push of solar radiation pressure to navigate the celestial seas. This audacious idea sent ripples through the scientific community, sparking a curious blend of excitement and skepticism. For some, this theory was tantamount to shouting aliens from the rooftops, while others questioned its scientific foundation. Undeterred by the controversy, Professor Loeb took up the gauntlet, penning a book that would delve deep into his daring hypothesis. This literary endeavor wasn't just a defense of his ideas. It was an invitation for both fellow scientists and the general public to embark on a mental journey exploring the tantalizing possibility of Oumuamua being an emissary from the cosmos. Within its pages, readers would find an intellectual sojourn, a profound reflection on the potential for an otherworldly encounter, and a robust examination of the arguments that had rocked the scientific boat. Yet, even as this intellectual debate raged on, Oumuamua wasn't done confounding us. In 2018, just as it readied itself to bid our solar system adieu, the ever-watchful eye of the Hubble Space Telescope captured its parting shots. What it revealed left scientists scratching their heads in bewilderment. Instead of the expected slowdown, Oumuamua exhibited an unexpected burst of speed. At first, some speculated that this velocity increase might be due to outgassing, the process where material escapes from a comet's surface under the scorching influence of the sun. But here's the catch. Oumuamua displayed no telltale signs of a comet's tail, and its rapid acceleration defied the laws of gravity. What's more, if outgassing were the culprit, it should have sent Oumuamua into a wild spin, a phenomenon conspicuously absent from the observations. It was this enigma that prompted thinkers like Bialy and Loeb to consider an alternative. Radiation pressure. This cosmic force emanating from sunlight could plausibly account for the observed acceleration. And so the puzzle deepened. If Oumuamua wasn't a run-of-the-mill comet or asteroid, what manner of celestial traveler was it? This enduring enigma continues to captivate the brightest minds in science. Oumuamua's behavior remained a cosmic conundrum, defying conventional explanations. Its radiant brightness, its unconventional form, and its mystifying acceleration challenged existing theories, all while refusing to exhibit the telltale signs of outgassing. Elon Musk couldn't help but connect the dots, observing that Professor Loeb's earlier involvement in Project Starshot, a venture aimed at propelling a miniature spacecraft to Alpha Centauri using a light sail and a formidable laser, had likely laid the groundwork for his Oumuamua hypothesis. As Oumuamua graced our cosmic doorstep, the notion of it being an interstellar probe suddenly made sense. Rigorous calculations supported this idea, providing measurements for the hypothetical probe's dimensions, composition, thickness, and reflectivity. Every piece of available evidence, scrutinized under the piercing gaze of scientific inquiry, eventually converged to one startling conclusion. Oumuamua was not a product of nature. While the light sail theory might strike some as unconventional, it adhered to a methodical, evidence-based approach. Loeb and Bialy adopted a scientific principle akin to the deductive reasoning of Sherlock Holmes. Eliminate the implausible, and whatever remains, no matter how improbable, must be the truth. Thus, they dared to propose that Oumuamua was an artificial creation, a hypothesis meticulously constructed from the limited breadcrumbs of evidence at their disposal. To be clear, we can't unequivocally confirm Oumuamua's identity as an interstellar probe. However, in the vast cosmic tapestry, it's a notion worth holding in our imaginative orbit. Elon Musk, who shares a close rapport with Avi Loeb, holds him in high regard as a brilliant intellectual. Loeb's avid interest in the quest for extraterrestrial intelligence led him to put forth the audacious notion of Oumuamua being an alien spacecraft, a concept that garnered limited acceptance among his peers, but greatly piqued his own curiosity. In a similar vein, Musk harbors aspirations of discovering extraterrestrial life and finds the prospect exhilarating. Yet, he advises exercising prudence when leaping to the conclusion that aliens are the immediate answer to enigmatic phenomena. Musk acknowledges that at the time, Loeb might have overlooked certain research avenues due to the constraints of knowledge. While Loeb's theory is undeniably thought-provoking, Musk emphasizes the importance of juxtaposing it with alternative hypotheses and maintaining an unwavering commitment to the uncharted frontiers of space exploration. During an interview, Elon Musk delves into the enigma encircling Oumuamua's trajectory and proximity to the Sun. He underscores a fundamental principle. When an object deviates from the established laws of gravity, an alternative force must be at play. While contemplating possibilities such as melting ice, Musk adopts a cautious stance regarding the leap to conclusions, particularly the extraterrestrial hypothesis. Musk refrains from entirely discarding the idea, but his preference is to refrain from immediate assertions of extraterrestrial origins as the primary solution. The central question lingers. What precipitated the atypical course of Oumuamua? In early 2020, researchers unveiled a spellbinding hypothesis surrounding Oumuamua, painting it as a celestial enigma that could rival the marvel of a hydrogen iceberg. Picture Oumuamua as a cosmic adventure propelled forward by the sheer might of pure hydrogen gas, akin to a rocket surging through the cosmos. The notion was nothing short of captivating, but upon closer scrutiny, it encountered formidable challenges. A scholarly treatise authored jointly by luminaries from Harvard and the Korea Astronomy and Space Science Institute raised substantial doubts about its feasibility. Professor Avi Loeb and his cohorts couldn't help but cast skeptical glances due to a myriad of complications. At the heart of the skepticism lay a perplexing paradox. The conventional processes responsible for shaping solid entities like Oumuamua seemed ill-suited for sculpting a hydrogen iceberg. The customary method involves minuscule dust particles colliding and coalescing incrementally, forming larger structures over time. Yet, when dealing with a hydrogen iceberg the size of Oumuamua, these particles would have to engage in repeated sticky collisions to burgeon further. However, the dense hydrogen gas surrounding them intensified these collisions, generating scorching temperatures that promptly vaporized the once solid hydrogen into a gaseous state. Consequently, the dream of kilometer-sized hydrogen icebergs, analogous to Oumuamua, took a nosedive because the building blocks couldn't adhere together. The scholars contended that the tried-and-true process of grain growth through adhesive collisions was a non-starter in the face of such high gas density. Furthermore, if Oumuamua had indeed embarked on its lengthy cosmic odyssey harboring a hydrogen iceberg within, it would have been a mission doomed to fail. These hydrogen icebergs would have swiftly dissipated into nothingness during journeys spanning hundreds of millions of years. The hydrogen ice theory, had it proven accurate, would have revolutionized our understanding, providing a compelling explanation for Oumuamua's peculiar cigar-like shape and its unorthodox non-gravitational acceleration. However, the scientific community remained undeterred, forging onward with a treasure trove of alternative theories, ensuring that the enigma of Oumuamua continued to thrive. Fast forward to September 2020, and a riveting new hypothesis danced onto the celestial stage, transforming Oumuamua into an elongated cosmic vagabond. Imagine it as a colossal cosmic dust bunny, a celestial cousin to those clumps of household detritus found nestled beneath furniture generated by the whims of static electricity. Elon Musk himself painted a vivid picture of scientists envisioning Oumuamua as a grandiose rendition of this commonplace phenomenon. According to this beguiling theory, Oumuamua sprang to life from the remnants of a comet hailing from distant realms beyond our solar dominion. In this narrative, Oumuamua's creation saga unfolded as cosmic dust gradually liberated from the comet's core coalesced under the relentless influence of solar radiation, forging this wayfarer of the stars. This cosmic vagabond embarked on a cosmic journey, a brief sojourn within the confines of our solar neighborhood. Its celestial lineage traced back to a long-period comet, a wanderer known for its leisurely celestial circumnavigation, often meandering far from the comforting grasp of stars, buffeted by the feeble pull of gravity and the unyielding pressure of radiant energy. Oumuamua eventually cast off the familial ties to its comet progenitor, venturing into the uncharted expanse of interstellar space. While this theory shimmered with allure, The relentless spirit of scientific inquiry compelled scholars to venture further into the cosmos of possibilities, ensuring that Oumuamua's enigma endured, shrouded in celestial mystery. After an extensive 4-year quest, the astronomical community unveiled a novel explanation in March 2021 that piqued the curiosity of stargazers worldwide. Their hypothesis dared to suggest that Oumuamua, the celestial wanderer that had puzzled scientists for so long, might be a substantial fragment of nitrogen ice. This frigid material was thought to have fractured away from a distant exoplanet in a solar system far removed from our own during its formative eons, a cosmic event unfolding millions of years ago. What made this nitrogen iceberg theory especially enticing was its elegant simplicity, offering a more plausible account for Oumuamua's perplexing behavior. Unlike the earlier conjectures that had painted Oumuamua as a rocky remnant torn asunder by the gravitational forces of its distant star, this revelation marked a significant departure from the initial extraterrestrial musings that had swirled around Oumuamua's discovery. While greeted initially with skepticism, the nitrogen iceberg theory gradually gained traction among astronomers luminaries like Scott Shepherd. The notion that Oumuamua might be a piece of an icy dwarf planet seemed increasingly credible, yet the cosmic case remained open, awaiting further scrutiny. In their tireless quest for answers, scientists embarked on experiments to explore how various types of ice, comprising hydrogen, nitrogen, and oxygen, behaved under analogous cosmic conditions. To their astonishment, they stumbled upon a revelation. A substantial portion of nitrogen ice could replicate the very characteristics exhibited by Oumuamua. The primary hurdle was measuring the elusive nitrogen gas, a challenge that telescopes of the era struggled to surmount. These meticulous studies unveiled Oumuamua's peculiar tail-like feature, reminiscent of a comet, yet concealed beneath its nitrogen composition evading detection. Elon Musk, a passionate advocate of the research, elucidated that these dedicated scholars also managed to pinpoint potential sources of nitrogen icebergs, such as dwarf planets and distant celestial bodies residing at the outer reaches of solar systems, akin to Pluto and Neptune's moon Triton. These distant worlds were known to boast nitrogen ice on their surfaces. Building upon these insights, the researchers proposed a tantalizing narrative. During the embryonic stages of a remote solar system's formation, violent collisions between planetary entities birthed Oumuamua, liberating it to journey through the Milky Way. As time passed, the unrelenting influence of the sun sculpted Oumuamua into its peculiar flattened pancake-like form, a theory that gracefully harmonized with the observed data. Nonetheless, this elegant idea was not without its imperfections. Professor Avi Loeb and Amir Siraj presented a counter-argument contending that the existence of Oumuamua hinted at the presence of numerous similar celestial nomads within our galaxy. However, assuming that these objects were entirely composed of nitrogen from exoplanets posed a conundrum, as the known count of exoplanets in our galaxy remained rather modest. This dilemma yielded two possible scenarios. Either Oumuamua was not exclusively constructed from nitrogen, or our estimations regarding the abundance of exoplanets were far from accurate. To unravel this cosmic enigma, researchers embarked on an exhaustive quest to ascertain whether the Milky Way harbored sufficient celestial matter to give rise to the multitude of nitrogen icebergs that seemed to traverse its expanse. This reservoir of cosmic resources could be likened to a celestial savings account delineating the available substance for crafting celestial icebergs orbiting stars. Musk, with his characteristic zeal, uncovered a sobering reality. For our galaxy to produce such a profusion of nitrogen icebergs, it would necessitate a transformation of tenfold the mass of all the stars into a hypothetical substance called exoplutos, an astronomical impossibility by any stretch of imagination. Adding to the challenge, Musk postulated that cosmic rays, those energetic particles from distant reaches of the universe, steadily eroded interstellar objects like Oumuamua over time. Factoring this into the equation, our galaxy would need a reservoir of mass thousands of times greater than its present stockpile. In the end, the resounding conclusion of the response paper left nitrogen in a precarious position, unable to bear the entire weight of the cosmic narrative. However, the cosmos remains a realm of spirited debate, with some scientists contending that Oumuamua-like entities are rarer than previously believed, while Professor Loeb insists on a higher density, suggesting the presence of multiple interstellar objects for every 10 cubic astronomical units. Others advocate for even scarcer encounters, proposing a solitary object per 333 astronomical units, a scale that defies human comprehension, spanning a cosmic expanse measured in sextillions and quintillions of cubic miles. In this intricate cosmic ballet, the nitrogen iceberg theory endures, awaiting further cosmic revelations to guide its destiny. Nonetheless, scientists with their undiminished curiosity once again turn their gaze toward hydrogen as a potential explanation for the enigmatic traits and origins of Oumuamua. In a revelation that dawned in March 2023, two astronomers wielding the tools of chemistry cast a luminous beacon upon the intricate enigma surrounding Oumuamua. They posited that Oumuamua, in all its cosmic singularity, was in fact a comet, albeit one donned in unconventional garb. Their hypothesis wove a tale where Oumuamua over countless eons had become a cosmic hoarder of hydrogen gas, entrapping this volatile element through its encounters with cosmic radiation. According to their intricate modeling, Oumuamua may have commenced its celestial existence as a conventional, water-rich comet, merely orbiting a neighboring star in a distant corner of the cosmos. However, the capricious whims of celestial forces eventually hurled it far from its natal star's embrace and into the boundless expanse of interstellar space. During this epic odyssey, those emissaries of the universe's cataclysmic events like supernovae played a transformative role. These high-energy particles had the power to transmute up to 30% of the comet's water ice into hydrogen gas, a fateful substance ensnared within Oumuamua's icy fortress. As Oumuamua ventured closer to our blazing sun, the escalating heat acted as the catalyst, coaxing the captive hydrogen gas to escape in a fervent jet-like outburst. In the vivid narrative spun by Musk, this unexpected expulsion of hydrogen gas neatly accounted for Oumuamua's peculiar and confounding behavior as it embarked on its departure from our cosmic neighborhood. Astronomers, their eyes alight with the glow of discovery, hailed this model as one of the most compelling elucidations for Oumuamua's mysteries to date, illuminating a path that suggested Oumuamua was not so distant in nature from the comets that inhabit our solar realm. In their quest for corroboration, these intrepid researchers unearthed studies dating back 4 decades showcasing the extraordinary capacity of high-energy particles, akin to those found in cosmic rays, to wrest hydrogen from water ice and imprison it within icy structures, a discovery that fueled the fire of their theory. Yet amid this cosmic renaissance of understanding, voices of dissent emerged. Professor Avi Loeb challenged the study's findings, contending that miscalculations had marred their estimation of Oumuamua's surface temperature, leading to a faulty assessment of the hydrogen's abundance within the icy wonder. In Loeb's view, this discrepancy rendered the theory's explanation for Oumuamua's observed acceleration untenable. Presently, Oumuamua remains distant, its return engagement with our probing instruments a remote possibility. However, astronomers maintain an unwavering optimism that future celestial surveys will unveil more cosmic interlopers akin to Oumuamua. Now enter the Pan-STARRS 1 telescope, the sentinel of the night sky, which first unveiled Oumuamua's presence in 2017, and with its remarkable capacity to capture high-fidelity images of the entire cosmic expanse every few days, possesses the vantage point to unveil even the most ephemeral celestial travelers. This technological marvel, as Musk eloquently pointed out, revolutionizes the art of celestial surveillance, enabling the detection of exceedingly faint objects such as Oumuamua. With the swiftness of these interstellar nomads, comprehensive sky coverage becomes paramount, for the window of observation for these cosmic wanderers as they traverse our solar neighborhood is but a fleeting interlude, a cosmic whisper in the grand symphony of the universe. Thus far, the annals of astronomical history have chronicled the confirmed visits of only 2 such interstellar vagabonds, Oumuamua in 2017 and Borisov in 2018. Yet, the prevailing belief echoes the cosmic refrain that a multitude of these celestial wayfarers awaits discovery. Regrettably, the opportunities to scrutinize them have been scant. In Musk's vision, NASA's gaze falls upon the James Webb Telescope as the harbinger of a new era in interstellar object investigation, an instrument poised to revolutionize our ability to decipher the chemical tapestry, origins, genesis, and environments of these celestial nomads. In the words of Elon Musk, this powerful telescope promises to unveil unprecedented revelations about these cosmic wanderers, unveiling their hidden secrets, enriching our comprehension of the vast cosmic panorama, and furnishing us with profound insights into these ethereal voyagers. Interstellar objects akin to Oumuamua are akin to cosmic troves of wisdom and wonder, and the James Webb Telescope stands ready to unlock their treasures. In the realm of celestial inquiry, the study of these cosmic envoys assumes monumental significance, granting us but a tantalizing glimpse of its mysteries. The detection and scrutiny of additional Oumuamua-like entities possess the potential to either bolster or debunk a litany of scientific theories concerning their birthright in the cosmic tapestry. But what about the prospect of paying a visit to these cosmic wonders? The notion of intercepting these interstellar interlopers has ignited the imaginations of many. Among the scientific community, there exists a resolute plan to engage with these celestial nomads as they journey through our solar dominion. The unanimous consensus is that procuring a sample from these enigmatic entities would constitute an extraordinary feat of human ingenuity. One visionary proposal entails the launch of a rocket into orbit poised in patient vigilance for the passage of an interstellar visitor. This audacious endeavor finds a kindred spirit in the European mission aptly named Comet Interceptor, poised strategically along the lunar orbit, ever watchful for the arrival of the next Oumuamua-like guest. Speaking of Oumuamua, its discovery stands as a pivotal milestone for humanity, etching a profound mark in the annals of our cosmic exploration. It ushered in an era of empirical confirmation, casting aside decades of speculative musings to provide the very first tangible proof of interstellar objects. Yet as of March 2023, Oumuamua has embarked on a solitary voyage, its trajectory carrying it far beyond the boundaries of Neptune's realm, and its ultimate destination tracing a course toward the distant Pegasus constellation. In its distant sojourn, it has left our telescopes bereft of meaningful observations. The enigma surrounding Oumuamua's origins continues to elude us, a puzzle shrouded in cosmic mystery. Initial computations hint that it might have emerged from the general vicinity of the brilliant star Vega, an astonishing 300,000 years ago. However, the Vega of yesteryears occupied a different celestial address, its present location a testament to the ceaseless cosmic dance. Even if Oumuamua surged through our solar confines at velocities approaching a staggering 59,000 miles per hour upon its entry, such speed could not bridge the cosmic expanse in so fleeting a span. Thus, the true genesis of Oumuamua remains ensconced within the shadows of cosmic uncertainty. As we conclude this chapter of our cosmic journey together, I extend my gratitude for joining us on this episode of Spaceverse. While your presence graces us, I encourage you to delve deeper into the cosmos by simply clicking the video on your screen, a portal to further riveting cosmic revelations and quality content. And remember, our journey through the Spaceverse is ongoing. Stay tuned for more mind-blowing cosmic content in the future. Until next time, keep looking up at the stars, for the universe is filled with wonders waiting to be discovered. See you.